Friends, in today's video lecture we will study three important type of defects in solids. Among three defects, first one will be vacancy defect. It is also called as Schottky defect. Second one is interstitial defect. It is also called as Frenkel defect. And third one is impurity defect. So in vacancy defect or a Schottky defect, this defect is obtained during crystallization. Some of the lattice points or position remains unoccupied by the constituent particles. That means when you do the crystallization process, in practical also we are doing crystallization of some solid substances. What is the procedure actually in crystallization? First we take substance which we want to crystallize. That substance get dissolved into a small amount of solvent. Then you have to heat that particular mixture for certain temperature, and then you have to cool that mixture, so that crystal again going to form. So during crystallization what happens, sometimes the settlement or the arrangement of lattice point at their proper position is not happen. That means some positions remains unoccupied of that particular particles. So that means there is some vacancies which is developed. In case of ionic solid, the vacancies are produced due to absence of cations and anions. Obviously ionic crystal is formed because of combination of cation and anion. Cation, that is positively charged cation, combines with negatively charged anion. So there is formation of ionic solids. So this ionic solid, actually when there is a process where crystallization takes place, sometime what happens, some lattice point which is formed by that cation and anion, that is going to remains vacant. Then this defect is also called as vacancy defect or a Schottky defect. In this ionic solid, the expected density of that solids is decreases because of some ions are missing, and as a result mass of that particular whole crystal is decreases, but volume remains as it is, and that's why density of such a solids we expect it is decreases. This defect is mostly observed in a solid which is mostly called as ionic solid, in which sizes of cation and anions are almost equal. So for example, sodium chloride, potassium chloride, cesium chloride, these are the examples of vacancy defect or the Schottky defect. Now second type of defect is called as an interstitial defect or a Frenkel defect. This defect is obtained when an ion in the ionic solid leaves a regular lattice site. That means ions or a particle from that solid which leaves their original position and occupy a position which is new, and that new position is formed in between the two regular lattice point or the interstitial point. That means in between two lines that ion is localized. That is also shown in diagram. So this defect is called as an interstitial defects or a Frenkel defect. So that is the difference actually you have to remember in a vacancy and Schottky defect. in between vacancy and Frenkel defect. In Schottky defect, what happened? The regular constant particle leaves from their sites, and that doesn't remain in that particular crystal. That means whatever the atom or the constant particle missing, it is completely missing from the solids. Here in interstitial type of or the Frenkel defect, constituent particle miss from their original site, but it does not change, or it is not going out of the crystals. It is remains in the crystal, but at a new position, that is called as a interstitial position. So Frenkel defect arises in case of solid with relatively smaller cationic size, which can fit into interstitial position, and the difference in ionic radii is large. That is another two important feature which found in a Frenkel defect. What is that? One is where cationic size should be smaller, and that cationic species occupy a interstitial space where the ionic radii is large. That defect is also called as dislocation defect. This defect is observed in a silver chloride solid where Ag plus ion is occupy an interstitial position. Second one is zinc sulfide ZnS, where Zn2 plus ion is occupy an interstitial position, and so on. The density of Frenkel defect in a Frenkel defect does not hamper; it remains as it is. In a Schottky defect, where we found density of that particular solid is decreases because mass is decreases, but in Frenkel defect density doesn't change because the particular ion, whether it is going to leave their position, but it remains in the solids, it is not going to away from that particular crystals, and that's why density remains as it is, because mass remains as it is, mass doesn't change. Now third defect is a impurity defect. In this type of defect, when cations from its regular site, or these defect is arise when a cation from its regular site in ionic crystal lattice is replaced by different cation. In impurity defect, what happened? One cation is replaced by other, but that other cation should be of impurity. If the impurity cation is substituted in the place of regular cation, then it is called as a substitution impurity defect. For example, I have a copper sheet. That means where all copper atom or copper ions are placed. But sometimes what happen? One of the copper ion is replaced by zinc ion. That means zinc is act as a impurity. So for this example called as a brass alloy. Alloy is the good example of impurity defect. If the impurity of cation is present in the interstitial position, then it is called as an interstitial impurity defect, like Frenkel defect. Impurity cation is present in the interstitial position. For example, I have iron sheet where all Fe atoms are there, and in between two Fe atoms, if there is some carbon which placed at the ovoids or the interstices, then it becomes an interstitial impurity defect. Alloys are formed by a substitution defect. For example, brass, in which copper metal is substituted by zinc in the ratio of 3:1 at regular copper site. Stainless steel another example. It is an example of interstitial impurity defect. Copper alloy is the example of what? Copper alloy is the example of substitution impurity defect, and brass alloy, or we can say stainless steel, is the example of interstitial impurity defect. What are the consequences of Schottky and Frenkel defect? That means what are the interesting points in between two defects? So first point is both of the type of defect is that the crystal is able to conduct electricity to a small extent by an ionic mechanism. It means in both cases what happen, electricity conduction takes place. When an electric field is applied, a nearby ion moves from its lattice sides to occupy the vacancy. Due to applying electric field, whatever the constant particles, they move from the lattice side to occupy a vacancy. These result in creating new vacancy, and another nearby ion moves into, and so on. That means one ion gets charged with other ions due to migration of one place from one place to another place due to the presence of electric field. This process of migration of vacancy and their nearby ion continues. As a result, they generate electricity in the whole crystals. That is the beauty of defect. Frankel defect brings similar charges closer, which tends to increase the dielectric constant of the crystals. And third consequences is the presence of vacancies lower the density of the crystals. It's shown. It also lowers the lattice energy of the stability of the crystals. Last point, which is again important for examination point of view, that is distinguish between Schottky defect and Frankel defect. So in Schottky defects, we saw some ions are missing from their normal sites. That remains vacant. That's what is called as vacancy defect. While in Frankel defect, ion lose their original position, but does it occupy a new position called as interstitial positions. There is density of such a solid does not change. There is no change in the dielectric constant in Schottky defect. The value of dielectric constant increases in Frankel defect. And fourth, it is noticed in the solids with high coordination number of ions. In Frankel defect, it is noticed in the solids with low coordination number of the ions. There are so many other differences, distinguishes given in the book also. You just go through this. So here is the last point of this chapter. So I declare here that we finished this very important topic, that is called as structure of solid. So we in next lecture we will start another new topic of inorganic chemistry. Okay.